Is it working, Katie? Okay. Hello, everybody. Welcome to one of the 5 events of B-Link Innovation. My name is Wim de Koning, and I am leading the B-Link team. And so that basically means that the whole B-Link team is taking care of all these wonderful events that we're putting on. And this one is about machine learning and how machine learning can actually transform the ag sector. And we're doing that in collaboration with AWS. And but I will introduce your speakers a little bit later on. Normally we do this face to face, and we invite you into the B-Link space. We are a business unit of Lincoln University based on the Lincoln University campus, and we would actually provide you with a drink, a nibble, and so that there is also networking. At the moment, of course, I can only offer you a virtual drink because you need to provide your own drinks and nibbles. So I hope that you did that. Let's get started. For those of you who do not know B-Link Innovation is, like I said, a business unit of Lincoln University, and we do 3 things. We connect people, and by organizing these events like these, and then hopefully people actually start to talk to each other or recognize each other or discover each other, and hopefully then they start to talk. And most of the time when people start to talk, hopefully collaboration will take place. If people actually start to collaborate, then magic happens, and that's what we call innovation. So that is what we do. Some housekeeping before we get into the real interesting stuff. This webinar will be recorded and emailed to you. There is a Q&A function at the bottom of your ribbon. So if you actually move your mouse, you will actually see that, and you can actually put questions in there. We will have 2 speakers this evening, and after the last speaker, Stefan, has finished, there will be Q&A, but your questions you can actually put in your Q&A function. You are muted, and so that is standard. So we really hope that you enjoy this. If you are enjoying this, please get social. Please look us up on Twitter, LinkedIn, or Facebook, and leave us your comments or look to connect with us. So without any further ado, I would like to introduce our speakers. We will have 2 speakers this evening, both working for AWS. We have Dan O'Brien, the Venture Capital Business Development Manager from AWS. He is based, or they're both based here in New Zealand. He will kick off, and then I'm being told the real juicy stuff will actually be presented by Stefan. So please hold on, please wait until you hear from Stefan, and then please give us your Q&A in the Q&A box. I will stop sharing my screen, and I will give the floor to Dan. Dan, it is all yours.
Thank you very much, Wim. I will just share my screen now and get that going. One sec. Just confirming this is coming through okay. Wim, can you confirm?
Yes, I can see your screen. Thank you so much.
Fantastic. Great. So hello, everybody. Thanks for having us today. So I'm going to talk with Stefan about the rise of computer vision in agriculture, time to experiment. And I think that's the one message we really want to get across now. It's a great time to experiment with tech in agriculture. The second message is get in touch with your New Zealand AWS team. There's Stefan, myself, and there are others as well that can help you get started. But I just wanted to start with that. It's a great time to experiment. A little bit about me. So as Wim has mentioned, I'm the Venture Capital Business Development Manager for AWS in New Zealand, based in Wellington, and it would have been great to be down there and join you in a drink. And thank you very much anyway for this occasion to talk today. It would have been great to be down there. I've got a link down to the Canterbury region with my family, farming family, the Elworthies down there, and also up in the North Island. So strong sort of affinity to the land. And in my role as a venture capital BD business development manager at AWS, I'm all about helping New Zealand startups win on the world stage with AWS at their wing. And I think in New Zealand particularly, we're excited about the what's happening in agri-tech and startups in that space. And the role has got venture capital in it because I work closely with the venture capital community and investors in this company that back these startups. I'm also a member of the Agri-Tech New Zealand Executive Council, and also work closely with our agri-tech function within AWS globally. So I'm going to speak for 15, 20 minutes on AWS and agriculture, some customer stories, and talk about computer vision, and then hand over to Stefan to talk about Edge and computer vision before we open up for Q&A. So being AWS, we're very customer driven. We love to start with customers. And this is a customer I'm sure many of you have heard of already because they've made many headlines. That's Halter. And this is Craig Piggott, the CEO founder in the picture here with their solar powered cow collars on a dairy cow just there. And this is a great example of what we love to see. They raised a Series B $30 million round earlier this year. They've gone through 4 years of R&D prototyping and are scaling now. With a great concept. And when I first heard about it a few years ago, I thought it was science fiction, but this is something that can globally scale and change the face of farming globally. That is being able to remotely control the dairy herd so that you don't have to get up in the morning in a labor intensive way and actually move the dairy cows yourself. This is what Craig said, rather than having to direct cows to the milking shed first thing in the morning, a farmer can use technology to guide the cows there and complete other jobs instead. So that's the automation piece, helping with the labor intensive part of the equation. He also said we can detect changes in behavior and the onset of physical problems weeks before a farmer can tell you visually. That enables you to go straight to the cow to help them a lot quicker than you otherwise would. And this is around that individualized animal health. They're not only good for the animal, of course, but consumers are demanding this as well. They want to know that the animal has been ethically treated well and in a sustainable manner. And so Halter, from the very beginning, we've been working with them. They accessed our AWS Activate for Startups program, which allows startups to access up to $100,000 worth of credits on AWS that you can use to offset services. We've got over 200 services. And Halter, in the Halter's case, they've used compute, data storage, IoT, and analytics services to collect all that data they are capturing from the collars on the cows. And our teams in New Zealand and around the world are working closely with them. We know, of course, if we step back, the challenges are massive, right? I mean, these figures are daunting. 9.8 billion people by 2050, so from the 7.5 odd that we are today. And agriculture uses 70% of fresh water globally, 50% of arable land, and produces 24% of greenhouse gases. And so these figures are huge. At the same time, if we continue the way we're going today, if we continue using current methods, one study by McKinsey last year shows that we'd need arable land the size of Mexico, that's 2 million square kilometers, if we use the current methods going forward. It's just not a way forward to continue as is. Current methods are not fit for purpose, globally speaking, we're talking about here, right? And so I guess there is also out there that movement of back to nature and organic farming, because there are some consumers who consider that scaled farming is not the answer, that we have to go backwards, well, or back to another form, rather, of farming, more traditional, organic. But this, many people believe, many experts, and this is Julia Wright from Coventry University Center of Agroecology, Water and Resilience, says, isn't it a case of back to nature or forward to high tech? Many believe this divide is artificial. In fact, the way forward is to apply this technology in a scaled manner, and you can solve the problem, the issue around yield, and also around sustainability. Once you have the data, once you know how to be precise about how you're going to farm. Because we know that organic farms produce between 20 and 50% less food than larger, more industrialized farms. That the yield is lower, so more land is required. So that question about the land required to feed 9.8 billion people, land size the area of Mexico would be even more if we went back to sort of organic farming. So that's not the answer either. And the answer, of course, is through technology. And there are three sort of trends that we think are driving this. There's total control environments. These are greenhouses, vertical farming style environments where there are sensors everywhere, where growth rate, water uptake, transpiration, shape, number, reaction to light can be completely controlled. It's only applicable for certain crops, but they do use, these sort of operations use a lot less water, 90%, 80% less labor, and zero pesticides, but they do have a higher energy impact because you need to power these things, right? There's growth here though. Vertical farms are worth, US $7 billion by 2025. The other one is robot revolution, automation, because we know that the labor issue in here and around the world is a big issue, right? And market for agri robots is going to quadruple to 20.3 billion by 2025. Those are estimates, and within that category, the one that's the most promising is the self-driving tractors and these tractor trailers. You may have seen these Monarch self-driving tractors that are coming online in North America, and these things are incredible with the automation they bring in, the cameras they have on the tractors, and these tractors even have an app store that you can design apps for. So that's the world we live in now, tractors with app stores. So the robot revolution, that's the second thing. And the third one is around precision and the rise of data, the end of spray and pray. We're not going to be spraying and hoping and covering a whole area without precisely knowing what is needed for that area. So the information is going to be understood for by the animal, by the plant, by the pasture. That level of detail is going to be there. So we know there's going to be a lot more data out there. There's going to be a question about who owns that data, and that's a question that needs to be asked. There's also going to be questions around the frequency of the data. It's going to move from a much slower frequency of capture to real-time and near real-time capture of that information. This applies to visual information as well, right? So there's sensor information from measuring things like humidity and the like, but also from cameras and the like. And capturing that data is one thing, but a harder thing I would argue is to gain insight from that data and actually have an analytic application. And that often is a result of layering data sets together and sharing securely data from other sources. That's where you gain the insights. So these trends are what we are seeing are changing the game in agriculture with technology. And there's a good article in the Listener from May this year, actually, a good 5-6 page, quite in-depth article. And there's a quote from Adrian Colony from Agritech Capital. You may not love the idea of a cow being milked by a robot compared with a person, but the cow prefers the robot. And that's, it's a sign of the times. So let's step back a bit and just look at what we do, AWS, Amazon Web Services, do in agriculture. And we'll start with what AWS does, full stop, right? It's all about cloud computing. And I want to just level set with the term, cloud computing. This means access to IT resources over the internet using pay-as-you-go pricing available on demand. So in the old world, in the old days, you had to, when you're building a tech solution, you might have to buy hardware, software, this operating systems, configure that. It would take weeks. It would cost a lot of money, and you couldn't actually get started on the project for several months down the line. So it cost a lot of money just to run an experiment in the old world before the cloud. With the cloud, of course, you just pay for that as you go. And if you hit onto something that works, you can scale it to your customers as you need. It's kind of like your light switch at home. When you turn on the light, you pay for the electricity. You don't pay for it when you don't use it. And so for startups and for businesses that are innovating, the cloud is really a game changer, right? That agility means you lower the cost of failure for experimentation. And that's the message I want to get through. That's happened for some time now in software as a service and in the cities, of course, with fintechs and that sort of thing. And we've seen great examples in New Zealand from customers ours like Xero or Vend or PushPay. And of course, around the world, Netflix is Airbnb who are doing that. But what we're saying and what we think and believe is that right now in agriculture, there's a convergence happening with connectivity and edge compute and the cloud and hyperscale compute. That means that cost of experimentation, the agility, is coming down a lot as well. So these are the 5 sort of reasons why people choose the cloud: the agility, the ability to experiment, cost savings, what I referred to earlier, being able to convert that upfront cost into a variable expense, the elasticity, being able to breathe in, breathe out. So matching the demand to your usage. So you don't have to provision for peak usage, maybe 2-3 years down the line. You just set it up for what the users need today. Innovating faster. You can focus on things that differentiate your business. Again, really useful for innovation projects within businesses or startups, because you don't have to worry about what we call undifferentiated heavy lifting. That is setting up the stack, setting up the infrastructure, setting up the operating system, the database, and having DBAs and the like. And you can deploy globally within minutes. And this is great for New Zealand companies. It's a real sets a level playing field for going global. In agriculture, of course, there's a little sort of twist to that, is that elasticity is often tied to seasons and harvests. And so you don't want to be paying for capacity and use when you're not using it, right? And also you're only going to be, normally your business might not be paid by your customers until that season, until the harvest as well. So there's that sort of angle to it as well. Connectivity, and in the rural community, of course, connectivity is not as high as in the cities. That's changing. It's getting better over time. There's still going to be, though, situations where connectivity is either you're in a disconnected state, or you have a lower bandwidth connection or a lower frequency connection. And so we have this concept of edge computing, and Stefan's going to talk a lot more about that in detail. And then finally, the point I just want to say here is around sustainability. We strongly believe that effectively, as mentioned at the beginning, to meet these challenges, tech and data are key to doing that. And we know that the primary sector and farmers have a long-term view when it comes to their operations. They're often intergenerational operations, and the cloud and tech is going to help with the compliance that's going to be required to meet the new way of doing agriculture. From our perspective at AWS, we have globally a very wide range of customers across the globe, from large businesses, small businesses, from different sectors. And this is the beauty of agriculture. There are so many different practices and variety, from the Bayer Crop Sciences to Cargill, to Nestle, to Figured, to Farm IQ. We have a very, very wide range. And we help customers in a variety of ways. These are three that you can talk to us about in another session, but we're going to focus on computer vision today. But we talk also about helping connecting up the operation via our connected farm workshops and discussions. The enriched agricultural data lakes, and this is where you can layer data sets together in one place cheaply, durably on the Amazon S3 storage service. And you can do this, you don't actually have to remove any data because the storage is very cheap, and you can do it immutably and just use it as you need it. And then we also have ways you can make actionable insights with analytics and business intelligence using that data. So you can talk to us about those subjects as well. Many of those customers are doing things in those areas, but today we're going to look at sort of computer vision. And we know that agriculture is data rich, right? When you have if you think about a soil in your hand, there's data around the the moisture content, the humidity, the acidity, and then the seedling itself. Visually you might be looking at it, and visual cues drive a lot of decisions in agriculture. And so we think if we look forward, what's going to happen is that in agriculture, kind of similar to what's happened with GPS and location. If you can rewind back to the 2006, 7, 8 era, I do remember that era quite well, and people were talking about how is GPS going to be used? Are there going to be GPS startups that do just GPS? No, what happened was GPS became ubiquitous. It was on everything. Everything has GPS. And this is a similar sort of thing that's going to happen with computer vision and sensors in agriculture. It's going to be applied across the board. It's inevitable in a way. But saying that, it's not like a fait accompli. You can't just turn it on. There needs to be some smarts about it. If you think about scaling human vision and putting it into a machine vision, right? And you look on the left here, what our human eye sees, we make a lot of predictions and inferences instantaneously when we look at this picture of these piglets, right? First of all, we know they're piglets. We have an inference about the age of the animal. We have an inference about which direction they're walking in, how many there are, etc. Now, when a computer, if you don't train a computer to understand, okay, for instance, I want to count these piglets coming into a lot, and these piglets are twirling around, and they're just counting the pigs, the computer is just going to double count or triple count the piglets, right? So when you train a model, when you can a machine vision model, you have to think about, in this case, where the piglet's head is, and measuring that when it moves across a threshold and not double counting it. And you train it using these bounding boxes to identify the different sort of pictures of the piglets' heads. And I often think of computer vision and machine vision as just sort of pattern matching. This trying to put into a machine vision model one inference that we make as humans, and especially a specialist, and I'm no specialist with piglets, but would have a deep understanding of things they see And you can bring that and actually make that into a model and sort of commercialize that. And that's the exciting part. And so we've got customers. I'll just go through a few more here before handing over to Stefan. We have customers like Hectare, who are in the horticulture sector, and they're helping with computer vision in horticulture and scaling that. They just last week announced a raise of capital of $3.5 million and stuff. And in that article, they mentioned how they're using AWS for this computer vision model called Spectre. And essentially what they're doing is they're increasing over 100-fold the number of apples that are sampled. In the old way of doing things, when sampling apples to understand their size and quality, a human was sort of using a measuring device to pick out 50 in a truckload of 100,000 and use that as a sample size. Of course, this has a huge impact downstream in the value chain, because the processors of the apples need to know the quality of the apples to see if they configure the machines for juicing them, or if they're premium apples that are going to go into a supermarket, right? And they have to reconfigure these machines if the sampling is not good. And so what they've done with this computer vision model is with over 90% accuracy, they've increased over 100-fold the sample size, which reduces those errors downstream. And they're winning business overseas in North America and elsewhere. They've benefited from advice from our team in New Zealand, including Stefan, who's on the call today, around how to design such a system using Amazon SageMaker and our other AI services. They've also benefited from our AWS credits startup program, Activate, as I mentioned earlier, to get started with free resources. Another one in New Zealand to quickly talk about is Cropsy, which help with computer vision in a viticulture and also horticulture context with these tractors of very high resolution cameras that can pick out the characteristics of the vines, right? And they started with the question, this is a big industry in New Zealand, $2 billion a year, but only 1% of vineyards are actually visually inspected or monitored for disease or improvements around yield and the like. What if you could scale human vision 1,000 times? That was the sort of prompting question they started with, and they've got these very high resolution cameras that are on tractors that can actually pick out and have individualized sort of animal plant health. They're using Amazon SageMaker, like products like Amazon SageMaker help Cropsy scale AI and computer vision solutions to the world's greatest wine regions. That's what Winston Su said, head of AI. They're working with Pernod Ricard, which is one of the world's greatest or biggest wine producers, French-based company that I know quite well, tasting their produce at least. So they've used the AWS Activate program again with Amazon SageMaker to train these models. So the great thing is that when you're training the models, you need a lot of data, and you can use this. You can experiment with the credit program, so you incur no costs on the platform. Last one I'll talk about really quickly is Curious, partner of ours, part of Spark, and Department of Conservation rather, and a Kiwi bird project they had, the Kiwi project rather, in Fiordland, where they were trying to detect or improve the detection of Kiwi bird call in the forest. So they had 8,000 hours worth of audio, which had taken 12 weeks for a scientist to listen to and just detect and hear the signals. So what they did is they just took a small sample of that. The scientist listened and annotated the signals after it had been converted into a spectrogram that you're seeing on the right here, using a computer vision model. And the computer vision model then was applied to the whole data set, and they were able to increase the time by 80% in terms of analyzing that information. So it's a good use case of like computer vision, again, a little bit different with sound and audio, but you can be creative with it, and you can do these things. So I'll just, in the interest of time, I won't go through this one around BeeWise, because I know I'm already at the quite near the, but this is an Israeli bee company using computer vision for colony tackle and colony caps. I can talk about that later if you wish. But we often ask this question: if you could capture visual information, what problems could you solve in agriculture? And that's the sort of question you should come to us also about. And so if you have some ideas, we can actually sort of bounce some ideas with you. It's a really good starting point. You've got to think big. You've got to think about new ways of doing things. And when you do get started, you can get started really quickly. We've got 3 layers when it comes to the AI ML stack on artificial intelligence and machine learning stack on AWS. We've got a top layer, an AI services, layer, which is really easy to get started, a matter of minutes to get started with, where you can easily add intelligence to existing applications. There's a service there called Amazon Recognition that is an image recognition service. There are many others as well, but this is one that you can use and integrate to identify objects in photos and the like. That we've trained and built that model for you. Then there's the machine learning layer, which is available for all developers and data scientists to build, train, and deploy their own models. This is where you own the model. You've got some secret sauce you want to commercialize, but you want to scale it, and you don't want to have to deal with that undifferentiated heavy lifting of managing infrastructure and the like. And that's where Amazon SageMaker, which I've mentioned, comes in, and Cropsy and Hector, for instance, are using Amazon SageMaker. And then at the lower layer, there's the machine learning frameworks and infrastructure layer. This is where you roll your own. You're very familiar with all the open source frameworks like MXNet, PyTorch, and TensorFlow, and the others that of course that are supported. And you have the fastest and lowest cost compute options available there. So that's what we look at. That's how it looks like for us at very high level. I'm not going to detail into the platform services just now. We have over 200 services, a lot of them. Just to end up again, cloud is like a fertilizer that creates startups. This is what Eric Ries said, and it's quite a seminal book in the startup space more broadly. Came out about 19 years ago. But I think it's really applicable now in the agriculture and technology space, ag tech space. We're at a place now where we're going to see a lot of startups, and New Zealand is leading the way. We're really flying the flag in the AWS team here in New Zealand for New Zealand ag tech. And yeah, just to leave you with the Amazon recognition, Stefan's produced this great blog on the AWS blog site to getting started easily for classifying kiwi fruit. Good little exercise. You can spend an hour or two to get yourself familiar if you want. And finally, from me, we also are working with Sprout on this horticulture challenge, which is recently announced. And this is a chance to win a great prize with them. But also, if you've got an idea in horticulture around some of the great challenges, water usage, traceability, genetics, automation, there's going to be a sort of like a Dragon's Den style pitch in front of some of the main actors in horticulture in New Zealand. That's going to happen in December, 10th of December, but there are entries open right now. I'll put this post on the chat link, this link as well. Don't hesitate to contact me on dubry@amazon.com. Any questions from what I said? And then finally, we've got this AWS Activate program that I've mentioned multiple times that you can sign up for free as a founder of a tech startup. And you can access up to $100,000 US as you go through investment rounds with the program. To start with the founders tier, you get $1,000 US. So that's that. I will now hand over to Stefan.
Cool, thanks, Dan. I'll just grab the screen.
Yeah.
Sweet. Can you just confirm that you can see that?
Coming through? Yeah.
Yes, we can.
Okie dokie. Hello, everyone. Yep, my name is Stefan Merton. I'm a principal solutions architect with Amazon, and I look after all the startups across New Zealand. Yeah, and I'm going to talk a little bit about computer vision and edge and how those two come together, and kind of what the state of the art is in that space nowadays. If one of my kids comes in and starts bumping me, sorry. Cool. So first, a little bit of a primer on where my opinion of where kind of macro level network topology is in the internet and technology these days. So the way I see it, we started with a centralized architecture. We started with the peer-to-peer. So those are back in the days of ARPANET and DARPANET and the like, where you had peer-to-peer connections. However, at some point, some of the nodes in the internet became heavier and started to bear more of the load. And you started to see this differentiation between centralized architecture and so server side and client side became a thing. So from there,
I'm starting.
Hold on. Go on out.
I'm starting now.
That's my daughter. So from there, you start to see that hyper centralization of some of those assets, the server side assets. And so that took the form of things like data centers and availability zones and local zones and all the other pieces of physical infrastructure that AWS relies on to deliver content and kind of commoditize compute for our customers. And so that moved toward more of a decentralized architecture. So in the beginning, we had data centers and they were monolithic. And then we started to create different levels of data centers, different levels of infrastructure that would serve users. And that differentiation continues in AWS land. And then third, what I think is starting to happen now is a move back toward a distributed model or a network-based model where individual nodes within the internet, within the network, are assuming more and more responsibility for the tasks that they're responsible for. So we want to have the nodes in the network tailored to the services that they're providing. And I'll talk about why that's important and how computer vision fits with that. Cool. So choose your own adventure. Yeah, edge versus cloud. So this is something I call, or I refer to as the spectrum of edginess. And that's that for any given node on the internet, it sits somewhere on the spectrum of 100% edge to 100% cloud. And so each of these is good for different stuff. So for example, cloud was amazing and disruptive because it created these centralized economies of scale. You could have a security specialist. I'm going to keep talking while I close the door so my 3-year-old son doesn't come in. You could have a security specialist that had 20 years of experience that was looking after your stack because it was hosted in an Amazon data center. You didn't have to buy hardware. You could distribute your machine learning training or your application servers across lots of hardware, and you could manage that with ease. So it was obviously a game changer. But the edge also has pros, and this is why you had a lot of people who wanted to stick with on-prem, wanted to stick with hardware for a long time. And so those pros are mainly around very low latency, quite a degree of customization of the hardware and the nodes, low ongoing bandwidth costs. You're not having to send stuff to the cloud, which as we consume more and more of our spectral bandwidth and as we want to push more and more rich high fidelity data sources to the cloud for processing, this becomes quite an issue, especially in agri-tech where connectivity is not always guaranteed. And then distributed localization, which is kind of the idea of having the right piece of compute and storage adjacent to the workflow that it's supporting. Cool. So as I mentioned, this concept, it's an unofficial concept of the AWS edginess spectrum. These are all of, well, some of the AWS services that are edge relevant and that help bridge that gap between edginess and cloudiness. And so I've kind of done some labeling here and stuff to give these some abstractions. You have sort of an abstraction around 5G, forward deployed processing for industrial applications, lower latency content distribution networks with Amazon CloudFront, local zones, yada, yada, yada. So that's kind of one brand of edge. There's also the brand, which is the Snow family, which is you have a bunch of data. You have 500 terabytes sitting somewhere, in the middle of nowhere, and you need to get that to the cloud. In some cases, the best way to do that is to pack it on a suitcase and ship the suitcase, or pack it on a truck full of hard drives and ship the truck, or whatever. So physical movement of data to the cloud. And then lastly, you have edge stuff, which is kind of robotics, IoT, microprocessors, microcontrollers. So those, we kind of refer to all those as edge. So it's a bit of a loaded term. But this is how I prefer to think about edge. So we've got a thing in the field, which is very edgy. So in this case, it's the FreeRTOS, which is a microprocessor, microcontroller, and it needs to get the stuff to the cloud. And it needs to negotiate that bridge between the edge and the cloud in a really elegant manner. And so this would be one route. It's kind of the brute force route. You just go from your microprocessor into the cloud by way of maybe a Greengrass core. Maybe it just sends directly via HTTP or MQTT. We don't know. But nowadays, there are lots of options there. So for example, if you don't want to just shoot, have an SD card or a SIM card in your microprocessor that's using cellular, you can use LoRa, or you can use cellular, or you can use store and forward, or you can use satellite. So lots of options there. You also don't need to send it all the way to the cloud. Like you can just send it to a local node that acts as a gateway to the cloud, which is what Greengrass is. So other things that are cool there is rather than having to send your 1080p 60 frames per second imagery up to the cloud to get processed, and then try to bring those insights back down in a time that's, with a latency that makes it relevant. You can actually do your machine learning training and inference against video streams locally via something that we call a greengrass core, or a local compute device with a GPU on it. And managing those devices is getting much easier all the time. You can also, if you wanted to, you could put it onto a snowball if it's big, or a snow device, and ship it. If you have 5G, you could always use 5G via AWS wavelength. If you have a local outpost that's kind of within 50 miles or something, and you wanted to tap into that, that can reduce the need to round trip to Tasman. And then there are a bunch of different ways of blending the cloud with your on-premise data store to get that data up and to get the inference where it needs to be as fast as possible and as cheaply as possible. So that is spectrum of edginess. Cool. So along those lines, I'm going to talk and do a live demo of a project called Project Evergreen, which was designed to make edge computer vision easy. So I basically just wanted to take, I have some devices and stuff here. I don't know if the cables will reach, I'll leave them, but I'll show you later. Take a Jetson Nano device, which is an NVIDIA Jetson, and I wanted to put a custom machine learning model on it so that it did something cool. And I thought that would be pretty easy, and it wasn't. So the project was to make that easy and accessible for farmer types or solutions architects or devs or whatever, because it was really hard. So in AWS computer vision land, we have a bunch of different services that do even computer vision. So you thought it was niche, but it is not. So there's a bunch of them. So there's Amazon Recognition, which Dan mentioned. This is cool. However, it's all cloud side. So I wanted to do edge side inference. So like, because in ag land, you can't rely on the cloud as much. So that was kind of out. SageMaker Neo, which we actually did use, this takes a machine learning model or a computer vision model and optimizes it for edge deployment. So use some of that. The Neo Deep Learning Runtime, which is a little runtime that lives on your edge device, like your Jetson, and it does inference well and fast. And then Amazon Ground Truth, which is how you take a bunch of images and label them and feed them into a machine learning model, so you can have a custom model that does something useful rather than just like object detection or whatever you get out of the box. And there are a few others that are actually mostly geared toward industrial applications and not super interesting from an ag perspective at this time. Dan kind of already talked about this one. So these are the 3 layers, lots of different machine learning services, AI services. Yeah, I think he probably said this well enough, but it's suffice to say that like, no matter what you're doing with machine learning or AI, no matter how big your team is, no matter how much training, whatever model you're using, you can do it. There's a thing for it. And navigating that can be a bit of a trick, but that's what Dan and I do. So you can just ask us to help. Cool. So why care about computer vision? I doubt that anybody needs convincing, but maybe they do. Maybe number 51 on the attendee list does. So computer vision is a big segment. From a market segment perspective, it's growing rapidly, very, very useful for automation. Right now, it's getting really heavy use in industrial applications, but it's this architect's belief that it's going to filter very much into kind of mid-market and SMB as it becomes more accessible. So some of the other relevant trends are that camera resolution and frames per second continue to increase all the time. So the bandwidth required to do computer vision from the capture source to the inference source is just going up. Cellular bandwidth, that everybody knows that spectral bandwidth is crowded, and so finding other ways to reduce the amount of data that's flowing across the wire is good. Decreased model and training inference costs. So actually doing your machine learning training in the cloud is getting much cheaper and much easier to distribute that workload. And that creates this kind of bifurcation between inference at the edge and training in the cloud, which kind of highlights which one is good when. And that handoff, that handshake between edge and cloud is getting better and better all the time. Inference hardware at the edge, like the Jetson Nano that I have here, is getting very cheap. It was really easy to get those until the global kind of microchip shortage. So it's kind of a pain in the behind to get one now, but I'm sure that'll get better, I hope. And then improved model management and deployability. So it used to be that like building machine learning was okay until you start to do it in anger. And then all of a sudden you got 10 models, you got 4 data scientists, which feature store are you writing to, which it just gets complicated. And so a lot of the stuff that Amazon's done recently is helping data scientists and devs manage all that complexity so that they can focus on business value. And then the last thing is that we have new connectivity types. So those are just some. LoRaWAN especially seems to be big in ag tech, and that's one of the places where we're putting a lot of effort to make sure it's accessible to our users. But then there's others as well, and I should probably add Starlink here at some point. Cool. Just check time. That's all right. Okay, cool. So this was the project Evergreen. So the goal was to take a Jetson Nano out of a kit like that, plug it in, roll some shell scripts, and have it doing cool custom stuff within 10 minutes. And I'm happy to say that we managed to get it much lower than that, just a few clicks, which is cool. So for all the nerds out there, this is the architecture that I used. So again, there on the edge, you have your edge device, which could be a Jetson or whatever. And that basically does two things. It either reaches back to a registry and pulls down a custom model that it can run inference on, or it runs inference, and that's kind of it. When it does the inference, it does the inference locally, and then it posts the results of that inference. In this case, we're using a binary image classifier. So it rather than having to post the whole matrix every frame of what it's seeing, it can post a 1 or a 0, depending on what class it thinks it's seeing. So it posts that to an API gateway, and then there's a container orchestration in the cloud that does the training and manages all the things. And I can talk about more in the Q&A if wanted. Cool. All right. So we'll get into the interesting bit. So what I'm going to be demoing is, custom image detection using not very much data on a couple of toy tractors that I have. So these are the toy tractors. And so my little Jetson Nano is going to be figuring out if it's tractor number 1 or tractor number 2. So it's a binary classifier. This can be quite tricky, actually, because you're trying to demo edge inference, which means that I have to have some kind of an actuator or signal on the device that's not going to the internet. And so in my case, I use a little LED, an RGB LED, that I have told to flash red if it's class number 1, I think, and then flash blue, I think, if it's class number 2. So I'll show you what that looks like. I'm going to be using a webcam to video a webcam. So if you start to get motion sickness, I don't know, feel free to go to the bathroom. Go. All right, so I'm just going to stop sharing here. Oh, that's not what I wanted. All right, so stop share, and hopefully you can see me. Okay, you're just looking at me now, I think. Yeah, am I full screen?
Yes, you're full screen.
Magic. All right, so I'm just gonna pull this up here. So this, do this. So this is my kind of Jetson environment. So on the left there with the big heat sink on it, that's a Jetson Nano. The little light there is my LED that flashes color based on the class that it's observing through the webcam. That's a Raspberry Pi there that's not actually doing anything. That's part of a different demo. And it's just connected to Wi-Fi using those antennas. And then attached to it is this little Logitech webcam. And so what I'm going to do is first, we'll share my screen again, and I'm going to fire up the terminal. Share screen, this one, share. Cool. So right now I'm just SSH'd into this little Jetson. So I'm just on a local connection over my Wi-Fi into the Jetson, and that's what this terminal is. And so what I'm going to do is on the Jetson, I'm going to run this little script. Let's do sooner here. I think that's right. Hope so. Cool. And so now it's just doing a bunch of stuff, validation. It takes a second to fire up. And then I'm going to take my webcam here and I'm going to post it, or I'm going to point it at, this could be tricky. I'm going to point it at my target. So I'm just going to switch hands here, switch hands. Okay, so that little LED is the one that is going to change, hopefully. And once my Jetson fires up and gets ready for inference, then I should be sweet. Should be any second. And oh yeah, cool. So now I've just got my little camera here, and you'll see as I waggle it around, it's got, it does different stuff. But I've only trained it on a bit of data, so it's not something to set your watch to. But now I'm just going to point it over here at my my tractor. And so white background helps. Yeah. So it likes certain angles better than others. And I'm trying to do lots of stuff here, so hopefully it works. So what I'm trying to do is lock in that class 2. So this is class 2, and it's hard to aim the webcam, honestly. It's kind of tricky. But what it should be doing, yeah, you can see it flashing here and there. So when I get the angle right and I actually get it pointed at the tractor, it's flashing the class 2 on the LED. And so of course, there it goes. With a bit more data, this would get better. But anyway, yeah, so there's the class 2, class 2, class 2. Cool. And so now I'm going to swap that out for the red tractor. And in theory, we should get slightly different results. So now you can see that it's hammering that red light, which is because it's able to detect that this is class 2. So again, it's a simple, very, very simple computer vision classifier. It's just using toys, but some of the cool stuff that I was able to do was, oh, there it's going. Oh, well. So I built an application that lets you capture the video just using your mobile phone. And then it splits that out and writes it in and then feeds it into the training DB and all the rest. But we were actually able to make it quite a bit more accessible for developers so that it's not quite so confusing, and managing the hardware and the edge stuff along with the cloud stuff for training has been is a lot easier. Sweet. So now I'm almost done. I'll just go back to my slide here, which says, are there any questions? And I think I'm good. Back over to you, Jim.
Thank you so much, Stefan. Thank you so much, Dan. The future will be technology driven. I think that is pretty clear. And so it's total control. And yeah, you were talking about the computer nerds, Stefan. I learned it's not me, but it's absolutely fantastic that you are that there are people out there that understand how to actually interpret the data that actually comes and make it into something that is used that can be used on farm, like for example a halter or a robotic milking machine. I want to open up for questions if there are any questions. I want to encourage people to reach out to Stefan, and then if they have more technical questions, please contact them direct. I'll make sure that I will share both emails of Stefan and Dan with you guys. I have a question here from Andy. What developments are there in low bandwidth, high availability data connectivity? Stefan, Dan, feel free to jump in.
It was what? So can you say it again? It was low band, high bandwidth, low.
What developments are there in low bandwidth, high availability data connectivity?
From my perspective, the big one. I mean, Starlink, I think, is one that's going to be high bandwidth, high connectivity, high reliability, but that's not quite here yet, really. The one that jumps out at me is LoRa, like LoRaWAN as a protocol for transmitting small amounts of information in a very power efficient way across significant distances is seeming pretty disruptive in ag. And then historically, that's been really difficult to manage, a LoRaWAN gateway and setup, but that AWS just released a LoRaWAN gateway component for our edge ecosystem. So it's getting much easier, and I think that that's going to get much easier and much cheaper in the next couple of years.
Thank you very much.
Nothing else to
Dan,
add.
go ahead.
Yeah, I was just going to say that we don't actually obviously run the connectivity networks. AWS doesn't run. So you know the network, you'd look at a provider of that service. Just a clarification point on that one.
Any more questions? Yeah, we have Frank. He is saying, great presentation, guys. Understand you guys like to help startup first. Wondering if you have any plan to engage research institutes or universities to form partnerships to back up the computer vision interference with science.
Yeah, I can take that one. Well, we do have plans to work with. We do work with universities for that matter, and part of the startup team is not on the call today, but Shane Tracy O'Connell his job is to interface with the teams at universities and help. Well, specifically entrepreneurial teams. We also have a public sector part of the business based in New Zealand as well, who can interface with teams in the science teams within universities when they're developing these solutions. And we have a AWS Academy and education team that are part of that. So I think probably the option there is to connect into that team. One thing we notice is that training is often a big question. So upskilling and learning how to get started is often part of those conversations that the AWS Educate team have. But do feel free to contact me about that, and I can bring in the right people.
Thank you so much, Dan. Any more questions, dear attendees? Well, thank you, everybody. Thank you so much. Thank you, Dan. Thank you, Stefan. That was fantastic. Dan put an email in the chat, and I will make sure that there will be an email of both Dan and Stefan when we actually forward the recording of this. Let's end up with the last question from Amos, and then we're going to end up. Love your work thinking about the ag sector. How do you communicate the value of edge computing to farmers?
Yeah, look, I can have my thoughts, and maybe Stefan also might want to talk about that too. I think from my perspective, the way to communicate it is it's really about making farmers' lives easier. They're not they might be the ones actually playing with edge compute themselves if they've got a technology bent to them, but they might just be a user of a solution which incorporates some of this technology. And as you know, with our smartphones, as we see every day, there are new smarts being put into the smartphone, which just make things easier and take a bit of pain out of our daily existence out each time. So that the same thing's going to happen in agri. And my view is that the providers of the technology to the sector will incorporate that. And I think what's exciting, and I think which is a great question, by the way, Amos, and it's always a pleasure working with you. What's exciting in New Zealand is there's so much innovation happening here, and we saw that at Field Days this year, where we saw so many examples of technology from large and small innovators in the sector. But that was just my thoughts. I don't know, Stefan, if you have anything else on that.
Sorry. As always, so I've done I've had the good fortune of working with a lot of field people in my day, and I think the key with any field person, so a non-analyst, non-nerd person, is that it needs to be dead simple, and we need to resist the urge to make it overly complicated. Like the goal should be to resist or to reduce the amount of time that field people look at their phone or look at their device or look at a screen. so that they can focus on why they're actually in the field. So anything we can do to just make a farmer's life easier without trying to make them into a coder, I think is kind of winning. Like if they could just hang around and sit in their field, pet their cows or whatever they feel like doing, go trout fishing, and the farm kind of runs itself until they want to intervene. Like I think that would be awesome. I think that's winning. Yeah.
Thank you so much, and I think that is a beautiful ending as well. Stefan, Dan, thank you so much for enlightening us with.
Sorry, I just wanted one little last interjection. My apologies. Just on that last point, effectively the Sprout Accelerator horticulture challenge that and Amos is on the line about it. I've just posted the link in the chat message there, and that's just for that. Like if you've got a great idea, you're a scientist or you're a student or you're in a business and you want to hear that and enter the challenge, please feel free to enter that. It should be a good one.
Yeah, and again, Dan, Amos will make sure that we have the link in the email that we send to all the attendees as well. And
cool.
Thank you so much for your time, attendees. Thank you so much for joining us, and please join us again live in the B-Link workshop. We are planning a Christmas wind down on the 9th of December. So if you are in the vicinity of Christchurch, you are very welcome. And then I can actually buy you a physical drink. Thank you very much and have a wonderful evening. Bye-bye.
Thank you. Bye-bye.